Okay, so in the last video, we started going over different symmetry elements, and the first was this proper rotational axis, which is a rotation by 360 degrees divided by n in a clockwise direction. We give it a Cn notation, okay? One thing I wanted to also emphasize here on this slide is that the highest order proper rotational axis, okay, meaning the n with the highest number, so the Cn with the highest number in your molecule, that is called the principal rotation axis. And we always define that to be the z-axis. It turns out we have to do that in order to make sure that all of our math, we're talking about the same thing. It's not wrong to call it x or y, but you will get an answer that all of us, the rest of the class, will think is wrong because you're using the wrong nomenclature, and it will be very hard to figure out where you messed up. So you just have to, the highest n is always going to be the z-axis, okay? X and y are going to be defined actually however you want. They just have to be, perpendicular to one another, 90 degrees. That actually doesn't matter, it turns out. It doesn't matter how you define x and y. The z-axis is always going to be the highest order axis, the principal axis. All right, so that's all on principal rotation axis. The next point, symmetry element, is called inversion or inversion center. This is given the nomenclature of just the letter I. Some molecules have inversion, some don't. What is inversion? What you do is you take the point XYZ, so any point has an XYZ, right? And then you look at the point minus x, minus y, minus z. And you look at if you get the same molecule back, if there's symmetry. And so the best way to think about this is sort of qualitatively, that's the mathematical way, is let's look at a point like here, okay? So this point we would say is in the top right of the page or of the slide, and it's sort of in the middle, okay? So I'm just gonna say it's in the top right. And so top right, the opposite of top right, well, opposite of top is bottom, right? The negative of top is bottom, and the opposite of right is left. So we're gonna take this top right point and move it to bottom left. And lo and behold, look, we got back, we went from a green atom of chlorine to a chlorine back there, okay? This point, you may be able to see, it's with the shadow here, it's supposed to be kind of in the front, this point right here, this chlorine. It's in the front of the slide. So it's in the front, it's at the top, and it's on the left. So front, top, left. What's the opposite of that? Opposite of that is back, bottom, right. Okay? And back, bottom, right gets you this point. So you could do that with every point here and find, hey, this atom goes to this atom, 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 right? There is an inversion center, okay? Same with this conformation, staggered conformation of ethane. There's an inversion center. This point is kind of bottom on the page, sort of, right? And then it's definitely on the left, okay? And it's in the front. Well, opposite of front left is back right. So this hydrogen would go to that hydrogen, okay? And again, a really good way is to go to this website. Cyclobutane, turns out, also has an inversion center. So if we hit here, it'll show us where the inversion center is. Well, inversion center is always in the center. So they just put a dot in the center. You're translating all the points from XYZ to minus X, minus Y, minus Z. How does that look like? All those atoms are going to go into the point. So top, left, back, went to bottom, sorry, top, left, back, went to bottom, right, front, okay? So anyway, that is all for this part.